Welcome to this session on Introduction to Large Language Models. My name is Shai Faranek. I'm a 28-year IT veteran, and I've had the pleasure of working across technology for most of my life. In the last 6 years at AWS as a global technology leader and builder within the Web3 blockchain space specifically. I presented 480 hours of content, 40 public sessions, and I've had the pleasure of being a senior fellow at AI 2030, as well as co-founder with William here for Philly AI Connect. I'm also the founder of Collins Forge, which is my independent consultancy.
My name is William. I've been in AI research for the last 7 years. Currently, I'm doing a dual master's in robotics and computer science at UPenn. I'm working on some neurosymbolic AI systems, and previously I've been doing research on computer vision. And before that, I've had some publications in brain-computer interfaces.
So first off, a large language model is a fairly new technology. It's a type of artificial intelligence. Language models are able to generate massive amounts of text, translate languages, and write different kinds of creative content and answer your questions in all sorts of different formats and in informative ways. They really do have the potential to change the way that we interact with applications and the underlying data there as well.
So how diffusion models work is basically you take images, step by step you add noise to it, and you train an AI to predict the noise at each step. Then you have the reverse diffusion process where you take a completely noisy image and then step by step you try to subtract that noise. Transformers are the most prominent AI architectures right now. It's grown in popularity because it has a large context length. For language modeling, we used to use recurrent neural networks and long short-term memory before. The downside with that is it couldn't really see words that are like long back in the history.
Again, agents, just like language models, are also new technology. But the key part is agents, because of the underlying components and architecture we're going to talk in a moment, are really the key part of what's going to help us revolutionize and automate a lot of the tasks that we do today. Language models can be used for a variety of tasks. For example, one of the ones I like in customer service is by iterating through a large amount of data, disparate customer history, and then in real time coming to a sentiment analysis with proper tonal response back to the user.
So I want to give a concrete example which is being built in a lot of companies right now. It's how you can have an input of an image and a text and then process it using a complex system of multiple agents to give you an output. Suppose you're standing in front of the Eiffel Tower and you ask, what are the best cafes on my way to my next destination? So to answer that question, you can't just give it to an GPT. You can't just expect it to know what your next destination is. So all of these are agents and tools. And first, it converts your speech to text. Then you give it to a VLM, which is a vision language model. You feed all of the data to a central agent. Now the central agent decides, or what other LLM should we call, to get the answer for this initial query that the user had given.
The prompt is a crucial component of the large language model architecture. This is what acts as the instructions, the explanation, the goal, the personality that instructs the language model how to behave. The prompt should provide context as well as to the information to the language model so that it can understand what you expect from it. So the tool is the key critical component here. The tool is optional, but we generally use it because it's going to provide that agent with additional functionality. The tool is just one piece, William, right? The language model is another important piece. So why is this important that we think through language model selection?
Before language models came out, we were using tools with like deterministic systems. Like we say, if this, then use this tool. If that, then use this tool. You give an image and a prompt, and there's like a central agent which decides which tools to call. So that decision comes from this world knowledge that is created from training. Whenever there's a query for data that's in your database, it'll go and query these documents that you have. Whatever matches the range of Tesla Model Y will come back to the LLM, and the LLM will craft the response for you. And then we have the evaluation, which is the last step of a agentic system. You saw how complex an agentic system can be. There's like multiple agents, multiple storage units. It's all producing data. It's all coming together, and you're giving a response to the user. So we need to make sure that whatever comes out of it should make sense. It should be filtered. It shouldn't be offensive. It shouldn't be biased.
It's really important that we actually evaluate that agent. We need to understand and have metrics to see how well that agent is performing, how well it's collecting the data, and how fast and how detailed it's retrieving that.
We are trying to do this community project where we are trying to build an agentic system with benchmarking. So I talked about AutoGPT, Crew AI, all of that they give you a framework to work with agentic systems, but they don't have benchmarking for agents. In the system that we are trying to build, we're trying to rank each agent for specific tasks. So if you guys want to join making this project, just scan the QR code and you can be a community volunteer.